So hello viewers, welcome to the Advanced Physics Problem Series. This is also a problem from Pathfinder for Olympiads and JEE Advanced Physics. This is problem number 31. Build up your understanding. Let us read the problem. A light rigid tube is welded along the diameter of a uniform cylindrical pipe of mass mm, radius r. So that is the pipe. Right through the diameter of this that is the tube rather. This is the tube through the diameter of this cylindrical shell. Okay, a bead of mass m connected by two identical light springs, each of force constant k, can slide inside the tube. That is the block B. I name the block as B. The pipe is held motionless on a horizontal floor. The bead is pulled aside at distance x as shown in the diagram, away from the center of the pipe, and then the pipe and the bead both are released simultaneously. If the cylinder rolls without slipping, find acceleration of its center immediately after the system is released. So I will present first the strategy for solving the problem. So I'll take the free body diagram of this shell only. So the let's consider the forces on the shell. So the force here, it is kx, and also there it is kx, and apart from that you have this weight, capital Mg, and also you have the normal reaction. What is this normal reaction? So this is actually the normal reaction on the block B, n downwards. And let us draw the free body diagram of the block. Simple as that. Block B, force is Mg, and normal reaction n is acting upwards. And now suppose the acceleration of this cylindrical shell be a, and the angular acceleration of the cylindrical shell be alpha. So the acceleration of the block B. What is the acceleration of the block B? So so there's the block B here, block B. So the acceleration of the block B is downward. So how much is the acceleration of block B? Acceleration of block B, AB, is equal to x times alpha. So we can write the force equation, Newton's law. Mg minus n is equal to m times AB. Now you can substitute AB is equal to x times alpha, and also due to pure rolling, A is equal to r times alpha. And next we have to write the torque equation for this cylindrical shell. Now for writing the torque equation of this cylindrical shell, see, generally in these situations we consider the torque equation from the center of mass. If you consider torque equation from the center of mass, there will be friction. Okay, there will be friction, so we don't know the value of friction. So you may need more equations. So the simpler way is to do that. So we can apply torque equation from the bottommost point P, and see there we can apply torque equation from bottommost point P, because the bottommost point P, generally if it has some angular speed, the bottommost point P has an acceleration upward towards the center. So anyway, considering torque from P, the torque due to pseudo force will be 0, and here actually the acceleration of P is 0 because this thing is at rest. If this thing is moving, then acceleration of P will be upward. How much is that? R times the angular speed square. But here the angular speed is 0. Okay, now see here I have written all these equations. See one by one. This so AB is equal to x alpha. Let's write this as equation 1. And force equation for block B, Mg minus n equal to m times AB. Let it be equation 2. And then next is torque equation about P, I'll write that torque equation about this lowest point P, because we do not want to find out friction. You can do it from center of mass, then one more equation will be the force equation for this shell. So I would like to avoid that. So find torque about P. So moment of inertia about P is 2m r square. So 2m r square times alpha is equal to, now the torque due to kx and kx will be 2kx times r, perpendicular distance is r. So 2m r square alpha equal to 2kx times r plus n multiplied by x. Because from the point P, the line of action of this normal reaction, that distance happens to be x. So, and obviously for the weight, the weight of the shell, there will be no torque, because that will pass through point P only. Okay. So the torque equation about P, let's name that equation 3. And next, for pure rolling, A equal to R alpha, let's name that equation 4. Now I'll leave that work up to you. And solving the 4 equations, what you get is this, what I have written here. The answer, A equal to xr mg plus 2kr by this and this.